Okay, let's just dive right in with a massive question. Is Earth actually the best possible planet for life? We've always kind of assumed we hit the cosmic jackpot, right? But what if our home planet isn't some five-star resort? What if it's just pretty good?
No, really, think about it for a second. Is this as good as it gets for life to thrive? Or is our planet just, good enough? For decades, our entire search for alien worlds was based on finding an exact copy of our own. The mission was simple, right? Find another little blue marble floating out there. It was basically the scientific equivalent of trying to find your car in a giant parking lot just by clicking your keys and hoping to hear that familiar beep. We wanted the same size, the same star, the same everything. We were searching for a cosmic twin, totally assuming that we are the gold standard for life. But then, a few scientists started asking, a pretty humbling question.
Yeah. What if Earth is the galactic equivalent of a C+ student? It gets the job done, but it's not exactly winning any awards. And that one simple idea has completely changed how we search for life in the universe.
So this shift in thinking gave us a brand new target. Instead of looking for Earth 2.0, scientists are now hunting for an upgrade. So welcome to the era of the superhabitable planet.
And this really puts our own planet into perspective. We think of Earth as this gentle, perfect cradle for life, but just look at this. Life here survives conditions that sound like they're straight out of a sci-fi horror movie. It just goes to show you that the window for what's habitable is way, way bigger than we ever thought.
So a superhabitable planet isn't just a place where life could exist. No, it's a world where the conditions are so perfect, so ideal, that life becomes practically an inevitability. It's a planet that's literally optimized for biology.
So how does our own planet stack up? Come on, let's give Earth a little performance review. We're going to check its stats against the ideal conditions for a true biological paradise.
We'll be looking at 3 key categories here. Think of this as the ultimate checklist for building a world that does life even better than we do.
First up, size and age. So ideally, a planet would actually be a bit heavier than Earth. Why? Well, that extra mass means more gravity, which helps it hold on to a thicker, more protective atmosphere. And it should also be older. Earth is about 4.5 billion years old, but complex life took a long time to get going. An older planet, say between 5 and 8 billion years old, has had way more time to cook up something really interesting.
Okay, now for the climate. Forget looking for a perfect twin. A planet that's about 5 degrees Celsius warmer on average, and therefore wetter, could have way more biodiversity. Just think about Earth's tropical rainforests, but on a global scale. More life, more diversity, more evolution. It's a win-win.
And this is where it gets really different. The ideal world wouldn't have our massive dry continents. Instead, the perfect planet would be an archipelago world, a whole network of islands and shallow seas. That creates tons of coastline, which is a fantastic incubator for life to make that jump from sea to land.
And finally, you have to pick the right parent star. Our sun, a G-type star, is reliable, sure, but its 10 billion year lifespan is actually kind of short for really complex life to flourish. M-dwarfs, on the other hand, live forever, but they're known for these violent solar flares, total anger issues. But K-dwarfs? They are the Goldilocks sweet spot. They're incredibly long-lived and way more stable.
Okay, so you might be thinking this is all just theory, but it's not. We've already found planets that are acing this cosmic performance review. So let's meet a couple of the top candidates for that superhabitable title. First up is this beauty, KO-5715.01. I know, not the catchiest name. It's thousands of light years away, but boy, is it already checking a lot of the right boxes. Just take a look at these highlights. It orbits a K-dwarf, our Goldilocks star. Check. It's in the perfect age range at about 5.5 billion years old. Check. And its potential average temperature? A lovely 19 degrees Celsius. I mean, on paper, this world is an absolute paradise.
All right, our next overachiever is Kepler-442b. This one is really interesting, especially because of its size.
So again, it orbits the right kind of star, a nice, stable K-dwarf. It actually scores higher than Earth on scientific indices that measure how habitable it might be. And get this, at more than twice Earth's mass, it has that super powerful gravity it needs to hold on to a thick, life-protecting atmosphere.
So, what all this really means is that our entire approach to finding alien life has done a complete 180. We have officially moved beyond the search for Earth 2.0.
We're not looking for a copy anymore. We're looking for a world that has taken all the ingredients for life and combined them in a way that might be even better than what we've got here.
And the best part is we have the tools for the job. The James Webb Space Telescope is already studying the atmospheres of planets like these, and future missions like Plato and the Habitable Worlds Observatory are being designed specifically for this new kind of search.
This quote really just says it all, doesn't it? The first proof of life we find out there in the universe probably won't come from a planet that looks just like ours. It'll likely come from a world that's bigger, warmer, older, and just better suited for the job.
And that leaves us with a fascinating, maybe even a little unsettling final thought. We've always seen ourselves as the pinnacle of cosmic evolution. But what if we're just the beginning? What if there's a world out there that has absolutely perfected the art of living? What would that even look like?